Hey everybody, happy Tuesday. Welcome to our first online lesson. Today's lesson is going to be on the topic of forces. May the force be with you. All right, let's get started. So we're going to start with our do now, like we always do. You should have your worksheet from Teams pulled up side by side with this video so that you can fill that out as we go through this lesson. So starting with our do now, you're going to read the following question and on your worksheet, highlight the answer choice that you think best answers the question and write at least one sentence explaining why you chose the answer that you chose. So today's question is, James is riding a bike down a hill. As he gets to the bottom, he applies the brakes to stop the bike's forward motion. Which of the following statements best describes an example of friction acting on the bicycle? So think about what scientific vocab is in that question that you need to know in order to answer this one. Choose the one you think best answers it and write your explanation. So go ahead and take 2 minutes. If you need more time after the timer goes off, pause the video. Otherwise, you can just keep going. All right, time's up. Again, if you need more time, just pause the video and then you can play whenever you're ready. So when we're reading this question, the words that should jump out are motion and friction. We have to know those in order to be successful in answering a question. So usually I'd have y'all raise your hands and show me what you're thinking right now, but you're just gonna keep your answer. At the end of the lesson, we're gonna come back to this and you're gonna see, do you still have the same answer or do you have a different answer based on what we learned throughout the lesson, okay? Hey everybody, what's our date today? March 24th, 2020. What's our topic? Forces. I miss when y'all do that. All right, today's standard, if you notice, we are working with a 6th grade standard today. We're going back a little bit. We're still keeping track on our remediation, going back and filling in gaps of material we may have missed in 6th and 7th grade, and just to refresh it so that we can make sure we cover all our bases before the end of the year, okay? So today's standard, we're going to investigate and describe types of forces, including contact forces and forces acting at a distance, such as electrical, magnetic, and gravitational forces. Our goal for today, we should be able to define what forces are and differentiate between the two major types of forces. Our vocabulary: applied force, electrical force, magnetic force, gravitational force, and we're going to spend a lot of time on that one. Normal force and friction. Our essential question, what are we working towards? What are the different types of forces and how do they act on objects? And lastly, you're going to be completing a 3-question exit ticket, which you'll find under assignments.
Okay, Sam, let's practice that kick of yours. Show me what you got.
Here goes nothing.
Okay. If you're gonna reach the goal, you're gonna need a lot more force than that.
It's not force I need, Mia. It's skills. I'm just not so great at soccer.
Sam, skills aren't gonna do you any good if the ball doesn't move. And if you want motion, you need force. Watch.
Now that's what I call a kick.
Thanks. What it really is force. A force is any push or pull on an object.
Alright, so with that in mind, let's get to our slides. Alright, so what is a force? I just told us in the video, it's a push or a pull upon an object resulting from the interaction with another object. It can act with or without direct contact, like without them touching each other. So if you're looking at this image over here, who is applying force to that box? Go ahead and take a few seconds to think about it. And you're going to be answering this question on your worksheet, so again, have that ready. Alright, so if we look at person A, what is person A doing to the box? They are pulling it. Person B, they are pushing. Oops. If we look back at our definition, force is a push or a pull. So who is applying force to the box? Both A and B. So when you're thinking about forces, there are 2 major categories. We have our contact forces, which are physically in contact, they are touching each other. We have 3 major kinds. What we just saw on that last slide, applied force, which is a push or a pull. The normal force, which is actually the force of the floor pushing up on you. So say this is Miss Hussein, this is me, standing in class. Horrible drawing. How come I don't just fall straight through the earth? Right? Gravity is pushing me down. What keeps me from going down, down, down into the center of the earth? That is the normal force. That's the ground pushing up on me. And the third type of contact force is friction. We're going to talk about that more. Then if we come over here, we have 3 kinds of non-contact force. Keyword non. That means they are not touching. And force is actually acting at a distance. So we have gravity, electrical force, and magnetic force. So again, we see our 2 kinds of forces. This is showing you some more examples of contact forces and our main examples of non-contact forces. Alright, so if we're first thinking about the non-contact forces, they are pushing or pulling without touching. Okay, so our first type is the electrical force. This is the force between 2 charged particles. Right? One, if you think about our charges, we're going to have a positive and a negative. What are those 2 charges going to do? They're going to attract each other. They're going to want to come together, right? So if those are coming together, you can kind of see in this image over here how if she rubs a balloon on her head, her hair is actually sticking up on the balloon like that. That's called static. Y'all might have experienced that if you touch something metal or come into contact with something and all of a sudden it shocks you. That's actually an electrical force. It's what we call static. Second type of non-contact force is the magnetic force. And we've talked about magnets before. They also have to do with charge, right? Our positive and our negative wanting to come together in attraction. But we also have this thing called repulsion. That's when if attraction, they're moving towards each other. In repulsion, they're going to want to move away from each other, right? And that happens when we have the same charge. So two positive charges, if you ever try to do this with two magnets, if you flip them a certain way, they won't come together because they have the same charge, right? They're going to actually want to repel or move away from each other. So this we see happening a lot in metals. Iron, cobalt, and nickel are all kinds of metals. And those are attracted to magnets, right? And our last non-contact force is gravitational force. This is the force of attraction between two objects with mass. Anything that has mass is going to have gravity, right? Like an apple falling on your head. Okay, so now if we think about contact forces, again, these are physically in contact. They are touching each other. So we have something like air resistance. This is also called drag, right? Air is actually physically, even though we can't see it, that air is physically touching the parachute, is moving up and pushing against gravity, right? So it's moving in the opposite direction. And another one that we have is friction. Friction, if our object is moving one way, kind of like this robot pushing this box up the ramp, friction is going to be that force that's moving in the opposite direction. Pardon my handwriting. Getting used to this. Right? So you might experience this if you're trying to move a desk across the floor. You can even try this with whatever pen you might be holding or something near you. If you toss it and it rolls for a little bit, but eventually what happens? It stops, right? That's because of this force friction. And the third one we actually talked about was the normal force. That normal force is doing what? It's pushing up against gravity as well. All right, so now we're going to play a little game. So on the following slides, you're going to see some examples of different types of forces in different scenarios. You're going to decide, is that a contact force or a non-contact force? And then can you be even more specific and describe which kind of force is it? Is it electrical, magnetic? Is it an applied force? All right, that's what you're going to try to do. Okay, number one, and remember you're writing your answers in your worksheet as well. So number one, I'll give you 5 seconds. Okay, so here our soccer player is going to be physically kicking the soccer ball. So that's going to be a contact force. Specifically what kind? Yep, he's pushing the ball, so it's going to be an applied force. Number two, 5 seconds. Contact or non-contact? All right, so first of all, what is this? This is a compass. If you think about a compass, if you notice, it has a north and a south, right? The red arrow is always going to point to north, the gray is going to point to south. But how does that happen? If you think about our Earth, we have the North Pole and we have the South Pole. Those two things are actually able to create a magnetic field around our Earth, right? Because in the center of our Earth, it's actually made up of iron and other types of metals. So it creates this magnetic field. So what type of force is it going to be? We already said a magnetic. And that is a type of non-contact force. All right, number 3. So you have to compare the two. In picture A, our little buddy is sliding down with ease on his skis. Picture B, how come he's not able to slide down as well? Okay, so what's that thing called? If he's physically touching the grass, it's going to be a contact force, right? He's physically touching it. Specifically what kind? Well, the grass is working against him. He can't move down smoothly. So that's going to be our friction force. All right, and lastly, okay, and what is this one? I know it's a little bit tricky because it is touching, but it's more like they're attracting each other. So again, this is a non-contact force. And it is the electrical force. Remember, the charges are attracting each other. Okay, so this is a little bit of a review. We talked about law of universal gravitation before when we talked about the solar system and how everything is held together. But remember that mass is that measure of the amount of matter in an object. So the more mass an object has, the greater the gravitational force between it and other objects is going to be. So if you have a bowling ball versus a ping pong ball, which one is going to have a greater gravitational force? The bowling ball. Yep, it has more mass, it has more matter in it. In comparison, when we think about distance, right, as you increase the space between two objects, the gravitational force is going to actually decrease, right? If we have two planets and they're moving away from each other, our gravitational force is going to get weaker and weaker and weaker. It's going to get thin, kind of like an airhead being stretched out. So we've also talked about this one before, right? We said mass is the amount of matter in an object, but weight in comparison is that effect of gravity on the object. So it might change when you go outside of Earth, right? So I want you to think about this question. What is the relationship between mass and weight based on the stick figures to the right? And you're going to actually write your answer in your worksheet. So pause the video if you would like to think about this one. Alright, so when you're looking at it, what do you notice? The mass for all of these stick figures is exactly the same. That means they have the same amount of stuff. But what do you notice about their weights? Why are they different? Look at where they are. If we start on Earth, our little guy is 140 pounds. But once we go to the moon, it went down so much, by 23 pounds. Why is that happening? Gravitational pull, right? The amount of gravity is changing when you go from planet to planet, right? Or planet to other solar body. Okay, so now if we come back and review our do now, we can hopefully eliminate some of these. So again, our question was, which of the following statements best describes an example of friction acting on our bicycle? We have A, the ground pushing up on the bike. So the ground pushing up, if you remember, is what kind of force? Yep, that's our normal force. So is that friction? No. We can get rid of that one. James's hands are squeezing the handle of the brakes. So if he's squeezing it, that means he's actively pushing it. That's going to be our applied force. Is that friction? Nope. Another typo. Sorry, guys. James's body is pressing down on the seat of the bike. So what's causing that to happen and him not to just float away? It's got to be gravity is keeping him down. That's not friction. So it looks like it's going to be D, but let's just read it to be sure. The surface of the brake rubbing in the rim of the front tire. So the brake itself pushing down on the front tire. So that is going to be working in the opposite direction of the way that the bike is going to want to move. So that is friction. So we can confidently choose D. If this one isn't making full sense, you have questions on it, text me, email me, or chat with me. We can work it through. All right, y'all, great job. We're done with our lesson for today. Make sure that you've gone through and completed all of your notes. Now you're going to take the next 10 minutes to do some independent practice on page 4 of your mission document in Teams. If you have any questions, you can post them in the class chat room channel, and y'all can help each other out in answering those. And lastly, once you finish that independent practice, you're going to finish out today's lesson with our exit ticket. This is what the title is, and you're going to find that under the assignments tab in Teams. I encourage you to use your notes to help you, and if you have any questions, again, I am here for you, and you can come during office hours as well. Good luck, y'all. Have a great day.